Okay, so we're going to look at some examples with the logarithmic functions. So the first example asks us to write the equation of the inverse in exponential form, then in logarithmic form. So remember that when you're looking at an inverse relation, you're essentially interchanging the domain and range, or in other words, you're switching the x and the y values. So if I wanted to write the inverse of this exponential function in the inverse form, I would interchange the x and y. So that's what I'm going to do. So I have x equals 5 to the exponent y. So I switch the places of the x and the y. And now because it's asking me to write it in logarithmic form as well, remember what we looked at in the video earlier. If you have x equals b to the exponent y, the x represents the answer when b is raised to a particular exponent. So in logarithmic form, remember a logarithm represents an exponent. In logarithmic form, this would be y equals log of x to a base of b. Okay? So if I look at what I have here, the exponent I'm looking for is y. Log of, the base that I have is 5. And the answer that I'm going to get once I raise 5 to that particular exponent is an answer of x. So that's how you would write it in exponential form. Okay, so if I'm looking at the second example, this one's slightly different. I'm looking at a base that's a fraction. Notice that it's still greater than 0. Remember, whenever you're looking at logarithmic functions, the base has to be greater than 0. And in this case, as the inverse, in exponential form, I would have x equals 1 over 10 to the exponent y. So again, I interchange the x and the y. And in logarithmic form, the exponent that I'm looking for is y. Log of, the base that I have is 1 over 10. And the answer that I'm going to get when I evaluate that is x. Okay, so here's the answer. There's the exponent, and the bases are there as well. Okay, let's take a look at the second example. So it asks us to write the equation of each logarithm in exponential form. So you're sort of working backwards. Remember that a logarithm represents an exponent, so this part here will be our exponent. The base is obvious at this point that the value is 4, and then the answer that you get will be an answer of x. So in exponential form, this would be a base of 4 to an exponent of y, giving you an answer of x. We'll do the same thing for the next one. Here's our exponent part. Remember, a logarithm represents an exponent. So we have a base of 2 over 5. Don't forget to put it in brackets since you're going to be applying an exponent to it. So you'll have 2 over 5 to the exponent y is equal to an answer of x. Okay, our next example asks us to rewrite each equation in exponential form. And so this time you don't have any x's and y's, you just have numerical values instead. And so in exponential form, we're going to write the base first. I think that's the easiest place to start, by writing the base. And remember again that a logarithm represents an exponent. And so this part here represents your exponent. So you'll have 3 to the exponent 4 is equal to an answer of 81. And you can verify that on your calculator as well, just to make sure that you're on the right track. So if I find 3 to the exponent 4, I get a result of 81. Okay, let's take a look at the next one. So this one's written in a slightly different order. Notice that the logarithm is written first, and then the exponent part is written last. So now we have a base of 7. Our exponent is 3. And the answer that we get if this is evaluated is 343. Okay, example 4. There we go. Okay, this one asks us to rewrite each equation in logarithmic form. So now you're sort of trying to go from exponential form to logarithmic form, and you don't have x and y this time, you actually have the exponents. So let's start by writing equals log, and we'll figure out what goes where. Okay, I know the base is 5 since there's an exponent applied to a base of 5. So that'll go at the very bottom. And remember that a logarithm represents an exponent. And in this case, our exponent is -2. So I know that's going to be on the left-hand side here. And the actual answer I get when I apply 5 to the exponent -2 is an answer of 1/25. Okay, so log base 5 of 1/25 is equal to -2. Or in other words, 5 to the exponent -2 is equal to 1/25. So the same thing for the next one. I'll start by writing equals log, and we'll fill in where the other values will go. This time the base is 2, so I know that the subscript here will be 2. The exponent value is 9, so I know that's going to go on the left-hand side here. And the actual answer I get is an answer of 512.